So today, we'll close out today talking about Edge, Fog, and SDN, looking at new technologies and how they're starting to be used in current corporate or data center type roles, but now focusing on how they could help us in control systems. When Dale first gave me this topic, I was kind of interested in it, so I actually reached out to Tobias Whitney, who was giving briefs on cloud infrastructures under EPRI. He was giving briefs on where cloud could take us in control systems of the future. So I was like, okay, this has got to be interesting. Let me look into this a lot further. There we go. Began looking at just plain information. When we look at data, all the way back to 1800 BC, we see how important it was. And in 1800 BC, we start seeing algorithms being stored on stone tablets. It was a kind of their version of the internet, the cloud, a book. They didn't have those yet, but they started storing this information on a tablet, and they started logistics information, data and financial transactions. Medical books, medical textbooks were dated back into 1800 BC. But whoever had data, whoever could share that data and comprehend it and assess it or process it into real information really had a leg up. Whether this was military, a business, it didn't really matter. We go up 2,000 years and we move up into the age of books. We go from tablets to some scrolls and probably in between, and now we're into the age of books where all of a sudden a librarian at the Yale University, he coined it an information explosion. And he stated, and this kind of sounds familiar today, where he predicted that in 16 years, all the American universities would double the size of their book volume. He also said that by 2040, that the Yale University would have 200 million books, and they would stretch across 6,000 miles of bookshelves. So that was his information explosion, the way that he looked at information. Information back then, they had large staffs and libraries to help categorize this information and be able to search for a volume of a book. But unless you read all the books on that certain topic, you weren't able to collate or process that information in a better way or more innovative way unless you were the human that read all those books. It wasn't searchable within the book. Now we look in today, and we have vast amounts of information. All this data that's being shared across everywhere, where you can pull us in, and all this information becomes power. When you can bring it in, process it, and make better decisions on it, all of a sudden you are decreasing your decision time, you're improving productivity, you're assuring the better quality of your products, and you're ultimately, we talked about dollars a lot today, but you're increasing the profits for that organization. Always taking steps back, this is S4x20, we've got to talk about cybersecurity a little bit. On the left, can anybody tell me what that is? Good. So that is the first telegraph. That was invented in France in the 1800s. And those, the windmills on the top, they could make different letters. Right over here, you can see the letters that they could make. And they had over 500 kilometers worth of these stations, hundreds of these stations across France. And they could transport information from the edge of France to Paris in about 3 to 4 hours, which the previous thing was a rider on a horse, which would take 3 to 4 days. Into this problem, we enter Francois and Joseph Blanc, who were bankers. They started working in Paris as stock market and the very beginnings of a stock market, and they realized that information and the speed of that information was power. And what they did is they started seeing financial transactions coming into France or from farms or other places that were manufacturing goods, and they could make decisions on whether to buy or sell a stock by adding a secret signal into the transmissions. They bribed some teleprompter guys that worked at the windmills, and these windmill people, they would send a signal, and that would tell them, yes, buy this stock, no, sell this stock. And from that, they operated as a kind of an advanced persistent threat back in 1834 for almost 2 years before they were eventually caught, because one of the guys that worked in the teleprompter area, the telegraph windmill, was sick, and he tried to pass on the duties to somebody else. And they ultimately got caught. France wanted to figure out what to do with them, but there was no laws, so they had to let him go. So interesting, we keep repeating these problems as we go along through time. We bring this back closer to us in industrial control systems. And in industrial control systems, we have these 4 functions where we're taking measurements, we're comparing them, we're computing them, and then we have a corrective action that kind of feeds back into it. And these are done by these elements where you have sensors. The sensors turn them into electric signals for transducers. You transmit them to a controller. The controller makes the decision and then has a control element back into the system. And when we move up in today's systems, there is a lot of real-time data that can give you full visibilities into these systems that make so much better. They reduce operational risk because of their ability to act so many times faster. You think of back plant in, say, like the early 1900s, and you had somebody that was going along analog temperatures and measures and pressures and stuff over different processes that were going. He only could do that maybe 4 or 5 times an hour. We're doing that thousands of times of hours and able to make corrective actions really, really fast with these systems of today. When I started looking at this, there was lots of different types of lexicon. So for today, I'm going to stick with edge nodes, which would be kind of like a sensor, like an IED that could be doing some pre-processing. We can look at edge servers, where now you have some applications or pre-processing that happens on them. And then we have the fog node, where this information is ultimately coming up to you. So you have like large amounts of information, but you're still keeping this on premise. And then you kind of can look at where maybe I need to share this information, or I need more permanent storage or more processing power. We'll talk about that as the cloud. The combination of a cloud and a fog node, you can kind of look at as a hybrid. When you're making your decision on whether this is good for your environment, and I'm really looking at this and stepping back and looking at this as an enterprise, vice just a control system side. I'm not just looking at specific OT, but I'm looking where all this information becomes really important to me. But you got to make decisions based on access, security, data requirements, and processing requirements. Who needs access to this information? Is this something that outside organizations need to see? Do you want all these outside organizations using up your bandwidth coming into your organization to look at this data? Or does it make sense moving it out to, say, the cloud environment or like a web type environment where that gets viewed there? Is only corporate needed? If it's corporate needed, maybe it makes more sense to be looking at more of a fog type environment where you keep that processing information closer to you. Again, if it's on an ICS engineering side of the house or proprietary type information, maybe you don't want that going outside of the edge sensors or the edge servers. On the security side, you might be a smaller organization that doesn't have the physical security requirements required for a data center. So now it makes more sense and you lean towards a cloud environment where now the cloud always has that resiliency. The data, you don't know where it's stored, it's just thousands of miles away from you, but it's out there and they have high redundancy where they lost one data center because of a natural disaster, that your data is still there and it's still right away there. Data requirements, I'm going to talk about that a lot with the bandwidth requirements. That's going to be one of the things that limits you from using a cloud, is the ability to, how much those WAN links will cost from all the information sources as we start to see more industrial Internet of Things within our environment, and kind of pushes towards an edge and a fog type solution. Also storage concerns. And on the processing side, look at the processing power needed. I'm looking at, as I look at this more and more, I look at the fog as covering your base. This is always the processing power that you're going to use within your organization. I look at the cloud as possibly being that extra oomph when, say, we're doing an audit or we have an inventory source and a single database is just getting hammered. Now we have the ability to instantly have more processing power or more memory on that. It's high, where the cloud is very, very scalable. Going into this, the first day that Dale told me, hey, Tim, can you talk about this? I ended up having beer with a good friend of mine who has a medium small size farm that he owns 4 combines. And we started talking about edge devices. And he took me out to his farm and he kind of just showed me how all this works for him. And I was blown away at the sophistication of a combine. There literally was at least 40 to 50 computers on this machine. He had the ability to, in where I live, it's really hilly. So the combine has to be able to change its center of gravity to be able to go on the steeper hills and the steeper slopes. So there was always that involved. He has cameras on it that are looking for areas of his fields that might have insects or need more herbicide. So he didn't have to apply insecticide or herbicide to the entire field. He could just put it on the portions that the cameras saw. And one of the really parts that really required edge processing is when he's seeding, there are samples being taken of the soil. And it's measuring moisture, it's measuring nitrogen, and it's measuring phosphorus. And from that part, it's making a live decision on how deep it should plant the seed. So that's the sophistication that's going into these things. But it kind of really emphasizes the importance of edge computing to be able to make those local decisions. He's out in the middle of a farm field. He doesn't even have 1G. So even thinking of like the bandwidth requirements, you're looking at each combine needing 20 gigabytes of raw data. The computer or the edge server on the combine has the ability to chew that down to about 5 to 10% of the data side after a 14 to 16 hour day. And he either has the option of sticking in a thumb drive and downloading the information and bringing it back to the farm, or once he gets it back to the farm, it has the ability to wirelessly transmit to his server inside. Another interesting aspect about this whole part, and this is going to kind of work into the part a little bit further on, is that he also has this aspect of real-time pricing for wheat. So if I'm a buyer of him, I would be looking at all the different farms that I can buy wheat from. Say that's the crop I'm looking for. He is able to then actually work this real-time stock market with the wheat prices between each of the places. And if I see that all the farms that I'm getting ready to buy from are kind of low quality this year, maybe some harsh weather all across that kind of hit and affect everybody, I might try to lock in a price with him early. And then if he agrees with it, he's looking like, wow, I'm getting a lot of offers, so I'm not going to lock in. There's like this bartering system that's going on real time between each other. They need a cloud environment that would best, the better he can get his data out there about the quality and quantity of his wheat or his crops, the higher the price he can negotiate with and compete with his competitors. But the one part from the Gartner part is that right now, in a traditional sense for Internet of Things, the data that's created, 10% of it's actually crunched inside of an organization. That seems like a low number to me, but this is their quote. But they did say by 2025 that this figure will reach over 75%, where the data crunching is going to happen within an organization and less is going to go out to a cloud or a data center. When you start, Cisco, when they start mentioning this term fog, the first time I heard fog was actually here like 3 or 4 years ago. I immediately thought of smog. But fog is bringing that processing power and that data storage closer to you. And Cisco coined it as whereas edge computing is the concept, fog is the standard of it. And it's supposed to be this a repeatable way of looking at things. Also on my friend's farm, he has weather stations that have cameras that he can look at certain parts of his crop field and see how things are going. He has drones based on the information that he puts into his server that tells where the crop dusters are supposed to drop a certain mixture of chemicals. He also has crop dusters that have cameras on them and other technology, as well as GPS to tell them exactly where they need to drop their loads. But that's where this whole fog concept comes in, is it doesn't necessarily truly make sense for him to put all that data into the cloud. He runs it from his house. He doesn't have to spend any more money for it. But if you put your cybersecurity hat on, who's providing that poor farmer any type of cybersecurity at all? And then I immediately started listening to Jason's talk, and I started thinking, what if you just changed it so that you planted the seeds wrong? Or you messed with the whatever formula that would cause a large-scale crop to not grow for some reason, what that would do to us. When we look at Internet of Things devices, 2015, they say there's 15 billion of them. By 2025, there's going to be 75 billion of them. And based on some calculations, they say that it's going to be 80 to 100 zettabytes of data per year from these devices. That immediately leans you towards the need to have edge processing and edge servers or a fog to be able to further crunch this down to make more economic use of your links up to the clouds. When I start picturing this in my mind, I started thinking of a control system type environment where you have the corporate side, you have a DMZ kind of between them, and then you have the OT side. I know, talking to customers, that we constantly have these people needing this data. To me, it makes sense to take all the metering data that you might be creating in an energy control system or whatever type of system that has that metering and bring up a read-only copy into the DMZ, and then from this information, they get an access to the read-only copy. I don't want to see finance computers reaching all the way down into the OT environment. I want them to reach into here where there's kind of a layer of a trust of what they should be able to get to. But you also have inputs into the system. The weather metering and all that other data from the weather sides of how cold is it, how hot is it, all that makes like energy control system data decisions on how much generation needs to be made across the grid in order for the system to operate properly. So that feeds back in, but again, do we want this system necessarily having to hook up directly to the weather, or can we bring the weather data into a more area, a centralized area with edge processing or a fog-like component? Same is true for event reports from a cybersecurity side. We've mentioned it a couple times today where we've alluded to that you could get a lot richer decision, a lot faster or comprehensive decision if we can combine OT data with IT events, OT events, and as well as the physical security. So again, I don't necessarily want these guys reaching all the way down into me, but if we could make up a read-only copy here that feeds up and all of that information gets combined into one place, then again, we can respond and recover or even detect faster. The SDN portion, I just kind of wanted to differentiate that the SDN technology that Schweitzer Engineering has for OT systems really has some amazing strengths. I can talk to you about that offline outside of this presentation. But I look at this as static. I'm not making dynamic flow changes. I can lock the communication from one device to another device, and that's all that can communicate over that channel. It also helps as the only way that you can do OT SDN like you should be able to do it, or you should be doing it from a security perspective, is you have to have a strong network diagram and you have to have a strong data flow diagram. So with those two things, now you're getting closer to that baseline assessments of what that system should be doing, and then the users can't make changes directly to it without coming to a centralized source. It's no longer plug and play. On the other side, on the corporate environment, now you're dealing with like a VM data center type environment, and you can be able to create flows on demand based on load. So if, again, like that situation where one database was getting crunched by a lot of people for a certain time, you can make a VM in another server where SDN would then guide the people like this side of the room into this database, this side of the room into this database to spread load that utilization up. So kind of going into the cloud technologies, advantages, disadvantages. The advantages of a cloud environment is, again, that ability to scale on demand. You just have to have that SLA or agreement made with your cloud provider. You have that high data resiliency. You might not be able to afford that equipment to do that on your own. And your infrastructure security has been transferred over the O&M and the maintenance of the physical hardware has been transferred to another organization where now you've locked it in just to a price per month or price per year for the space that you need. Disadvantages, when we look at all that data that these sensors are creating, you can't send a cloud raw data. I mean, it'll be just the WAN links alone will be too much. And I look at many of my customers on the utility sides, they're still using modems, they're still using DSL, they're still using T1s. So you're just not going to be able to fit all that raw data through it. I kind of look at Dragos with their ability to ingest data into their midpoint sensors, crunch it down, and then about 1.5% to 3% of that data gets sent up to the site store. That kind of model, and you've kind of got an edge sensor or edge server, crunching it down and then sending it up to a further place for it to all be collated into from all the midpoint sensors. It kind of follows that same model and fits where you might have some of these low bandwidth feeds. And then where the network, you always have to encrypt your traffic between you and the cloud. So the cloud environment, and you may be tricked or other things where that data could be moved in another direction or stopped from getting to the cloud. So you can't always trust that network. From the fog technology, because you're bringing that data or that information closer to you, you're increasing your proprietary data security. You also bringing the crunching power to crunch it down faster. So when you're starting to make decisions on a larger scale, say maybe with distributed energy resources or within an industrial control system, like an industrial plant, that data analytics, having it all in one place closer to you, means that it'll always be there when, even if you lost your WAN connectivity up to the cloud. And again, kind of like the counter of the cloud, the fog, you reduce your WAN bandwidth. Disadvantages, you need to have the equipment, and you're going to have O&M cost, and you're going to have personnel, both from the physical O&M of the equipment, as well as cybersecurity, as well as database. And even with the cloud, you're going to have some of that on your own too, but at least you get rid of the cost for the equipment itself. Edge technologies. Now we can start losing that latency and jitter and have a more deterministic environment. So you're kind of looking at a modern day relay or intelligent electronic device where it can make a decision on its own. Even if it's lost connectivity with the fog or up higher, it'll still be able to make an intelligent decision without having to rely on it. Definitely a reduction in the LAN bandwidth, but now you have more devices, more assets to keep track of, more things that you need to update firmware on, and you can kind of look at requires a local decision to be made. That is kind of both good and bad on the aspects of that. We'll take a step back, and I'm going to look at this since it's the end of the day and I'm only thing between you and your favorite beverage. I'm going to look at this from I'm a brewer. So all the things of the data that is most important to me that could help me make a better decision as a brewer that has thousands of customers. I'm going to have a supply side where I need information from those farms, or maybe I own some of my own farms. Things that are going to be super, super important to me would be when these crops are going to be finished, and I'll kind of go that in a little bit. But then there's a logistics tail, both getting the grain and everything to me, as well as sending it off. And then I have everything, my proprietary data and things within my control system. But then I also want information from customer satisfaction to how much is sitting on a shelf. And we'll kind of touch base on all those kind of the different parts. But this is the data I'm looking for if I was an owner of an industrial company and I had to make all these decisions. And if you look at Schweitzer Engineering, we do this from a supply chain security to qualifying suppliers all the way down, and you look at us with our 10-year warranty, you can look at us how much we care to make sure that that device is never going to have an issue with it. So we look at this from a Schweitzer Engineering point of view too as well. So all that data that I'm looking for that is important to me as a grower, I might want to know if, as soon as possible, what kind of crop yield and what kind of prices. We kind of briefly talked about that, where that's a really important data to me. But this data is also important because it's going to be how I'm going to be ready to be able to take the grain in and all those hops and everything else, all the aluminum and glass and cardboard and other things that I would need as a brewing manufacturer. I would need to know this information of when it's going to arrive. If I could get into the data of their equipment health, that might make a decision, a risk-based decision, on whether I should use one farm or another farm. So if I developed or I paid for that data from that farmer to be able to see the health of all of their combines, then I might be able to make a decision. Well, I can see that they haven't maintained these two tractors, but I know that this other farm has. They have about the same price. Well, I'm going to lock in with them. So there's different information in here that would be really rich that you can start looking at. That all becomes important to you. From the farmer point of view, this information he puts into his system, and after he seeds, it starts telling him already his harvest dates. If everything, and it looks like the future weather, like predicted, it has like the really sexy farmer's almanac that really has a lot more than what we get like as normal people not paying for it. But it actually, all that feeds into the system to be able to tell him already what his quality and quantity of wheat will be forecasted. 1,000 things could happen in between. One hailstorm could wipe out 40% of his crop. But at the same time, that information is there for him to actually start being able to make decisions on. We look at the logistics tail. I might have my own fleet of vehicles, or I might contract it out. But knowing the vehicle maintenance, how the driver's doing, are there strange weather that's going to delay his vehicles from reaching me by a day? Of course, he's using the driver of the vehicles using navigation, but the vehicle mileage and the security of the roads that day all kind of factor into this. You also are instantly able to kind of real-time what's your cost going to be for the logistics. So if there was a storm and they were out there for 2 or 3 extra days and stuck for getting your supplies into you, then someone's going to have to pay for that within the contract. I went to Anheuser-Busch earlier in the early summer last year. And it was astonishing how fast they could bottle beer. I mean, they were literally doing 2,000 12-ounce cans per minute. They were also bottling 1,200 bottles per minute, and they were also filling 1,600 20-ounce cans per minute. And the most astonishing factor about all that movement was the fact that it never stayed in their warehouse. Once it was packaged, once it was labeled, once it was out the door, it never stayed in their storage facility longer than an hour. If it was there, something had gone wrong. So, I do too. Yes. But it is amazing to be able to think about all the things that they are monitoring to be able to do that just in time. Logistics for something that massive. It is a 25-mile conveyor belt from the second the bottles are taken out of the beer and the box goes one direction and the beer goes to another from homogenization, but 25 miles of conveyor belts on that. So when it goes through the system, there's a lot of things that they got to be thinking about. Of course, they're probably thinking about the safety and the quality, as well as forecasting. They are having to get data from others to be able to determine how much beer they should be making. It takes about 3 to 8 weeks to make beer. So you really have to forecast this and guess ahead of time. But the more data that you have, the better decisions you can make on that data. And then we can kind of go into the wholesaler or the retailers, where I might have a lot of beer sitting on the shelf that's coming up to the end of product life. I got to slow my production down, and then I got to think of maybe a marketing campaign, a local marketing campaign. Maybe it's a regional problem one area is just really low, or maybe I'm forecasting like Miami is right now. Think of how much beer or extra alcohol or food or everything else that they're ordering in order to have a Super Bowl here on February 2nd. So maybe I can take more risk and make more beer right now because I know that Miami is going to be sucking up a large amount of it. I just got to make sure I can logistically get it down there. So all these are data points that sensors are giving us within control systems that help make these decisions and better decisions for us. They definitely come with a lot of cybersecurity issues that we must have to take, that should be designed in these systems. But I look at like the fog as being a great answer to having a hot site for a hot operations center where you have a fog that's automatically replicated to another fog at a distant location within a large-scale energy control system. And then if one dies, the other immediately takes over. All they need to do is shift people or have the people there that they can automatically start running it. So there's different advantages of this type of information, and I also really like the idea of allowing the people of corporate to do their job, but on a read-only copy. They don't need to reach all the way down into the system itself. So those are some of the things. I'm finishing up a little bit earlier, but maybe I'm thirsty. But the computing technologies, it really provides, this data provides that holistic view of intermixing manufacturing, industrial, any big system that you're looking at that stretches across as a wide area or across states, or even that farmer. I mean, he's already showing he has a small fog in his house where that information from all of his devices feeds into, and he can keep it historically. But it's kind of interesting where that data can take us. But with that, I can finish, but we got some time for some questions.
Yeah, we have time.
It's a different sort of topic, but
yeah, for some Q&A here. Who has a question?
So what security measures do exist to prevent the early problem you highlighted with the relay signals from being introduced along this digital chain?
which signals? Is that mic working?
The relay, the telegram relay.
Oh.
You know, the falsifying of data or inappropriate.
Okay, so the one thing that they didn't do in their procedures for the windmill is when a mistake was made, they never logged it. So as I was writing out the letters, when the mistake came, they immediately sent another signal like, oh, that was wrong, don't record it. But they never wrote down, if they would have just put a check mark there, mistake made, and then all of a sudden, next day, mistake made. Why are all these mistakes being made? That's kind of weird. And then why did they make this signal that is not even in our library of signals? So it was more along the lines of authentication and integrity. So they had no form. And it kind of goes back into a level of trust with the teleprompters. I mean, the people that were actually making the signals, they were getting bribed. So they had like kind of an insider threat where you have this steganography being used to hide information within other information.
Yeah, but I mean, couldn't that be introduced into the modern technology
Yes.
the same way?
And that's why I like that example.
What do we do? What do we do to prevent that from happening today?
I think it goes back to, forgot who had it very, very early on for the cybersecurity framework, where we really, really do a good job with identify and protect. We don't do as well in detect, and we need to get there further with respond and recover. It's that detection. It's having the ability that you're monitoring this. It's got to be, if you look at the risk management framework, the big emphasis on that, continuous monitoring. So that had no system monitoring those errors or any way of being able to send that signal. Same thing is true. We tend to see the techs and the engineers silo away from us, and they want to keep those event information local to them because they don't think it's important to, either they don't think it's important to anybody else, or they don't want to share that information to others as well. So for instance, I log into a relay. the relay sends a signal to our version of a PLC, a real-time automation controller, you have the ability, the RTAC has the ability to convert that into a syslog message and send it to your SIM. But that's traditionally not done because they just like, why would they need it? This is my Wheaties. This is not. So it's kind of like stovepipes of excellence, where we've kind of got to get that through those cultural gaps of here's where that information really would be important. When I have this conversation, I typically look at it from a point of view of if you are compromised, how would I be able to tell all the other devices that are compromised as well that are going to have to be recovered? And that you're going to have to check to make sure the settings and everything is correct on them. So in that aspect, if you are continuously monitored and you have a detection system that would be able to tell you that data, that all these devices were looked at, and all these devices, because the same thing with the RTAC can tell you if the firmware's been changed, it also can tell you if settings have been changed. It can tell you what access level that was logged in and send that up to the SIM. So now you'd have another part where whoever was aggressing at the network would have to go to even a greater length to cover their tracks by stopping that syslog message from ever being sent to the SIM. So you're just making it, everything that you do is adding another bar of difficulty for the attacker to get what they actually wanted to do, especially if they were supposed to do it without being detected.
In regards to like the farming slides and the food production slides, you mentioned that it doesn't leave farmers or with a lot of security options or like so I guess my question is, what can farmers do in order to protect themselves, or would they just be relying on your guys or on the software itself, or like what can they do?
I think we need to do better at providing advice. We provide a lot of great CISA type advice, or advice comes from DHS, but it doesn't help the small guys. It doesn't help my wife who owns a small independent insurance agency they don't even, it's magic how all that all works. They don't have anybody from the IT side in these smaller organizations. So we really should get better at either making it easier or helping them realize that these are the things that you should do. If you can't do them yourself, you're going to have to somehow contract them out. But changing your passwords or updating the firmware on your cable modem or your switch or all these things that you're kind of blind spotted on that would be hooks into the systems. SEL is a big organization. We've got 5,400 people. So it's really easiest for us to have campaigns of, hey, this is what phishing is. Here's what this is. But if I look back and I look back, you don't get that from just, I don't get internet email saying, hey, here's what things that you should do for a phishing attack. It's usually me telling my friends on what to do. So we do need larger awareness campaigns for these organizations that are 20 people and smaller. And you look at what they could possibly be used for. And the DDoSes that are thrown from multiple thousands of computers or Internet of Things devices that aren't updated or patched. It's definitely an awareness campaign that I've been kind of sensitive to just because of my wife's business.
Please join me in thanking Tim.
Woo.